If you have two variables, then we typically denote these variables by x and y, and we denote the sum by x plus y. For example, in Excel, if I have two variables, x and y, x being 7 and y being equal to 2, I can calculate the sum simply by writing equal to b1 plus b2. Alternatively, I can use the auto sum function right here and write it as sum b1 colon b2. If you have more than two variables, then using one character for each variable becomes difficult. So with more variables, the most common way in mathematics is then to use subscript. We use one character, for example x, and then we use subscript. So the first variable will be called x1, the second one will be called x2, and if we have three variables, we call the third one x3. In Excel, it may look something like this, and I can sum these numbers just like before. Clicking the auto sum or writing sum b1 colon b3 will give me the sum of these three numbers. The notation here for the sum will be x1 plus x2 plus x3. So this final expression, x1 plus x2 plus x3, I can write that using the summation sign. I begin by writing the summation sign, which is the capital Greek sigma. I identify the lowest index on the x variables that I want to sum. The lowest one is 1, so I type I equal to 1, and then I identify the highest index, which is 3. I put the 3 here, and then after the summation sign I put xi. So this should be read the sum as I goes from 1 to 3 of xi. So you can think of this as a loop in programming. So this means exactly I starts at 1, then I have x1, then to that I should now go to the next number, which is 2, and then to the next number, and that's the final one because 3 is at the top of the summation sign. In terms of Excel, you can think of this simply as this sum b1 colon b3. The I variable here in this summation is what's called a dummy variable. Basically means that it doesn't matter which variable we use, so I could just as well have written it as j equal to 1 to 3 xj. That would be exactly the same thing. Now I should just do a loop where j goes from 1 to 3 and calculate xj, and that becomes exactly the same thing. So a couple things to note. The numbers below and above the summation sign must be integers. The upper one must be at least as large as the lower one. The lower one doesn't have to begin at 1. So for example, summation I goes from 2 to 3 of xi would then just be x2 plus x3, which in Excel would be sum b2 colon b3. Here's another example. I have 10 variables. These are the values that the 10 variables take, and here I have summed these 10 values and found that the sum is 24. I write here the sum as sum b1 colon b10. In mathematical notation, that would of course be summation I goes from 1 to 10 xi. So I can write this as x1 plus x2. Then I can continue writing all the variables all the way up to 10. Typically, we are too lazy to do that. So the most common thing is to write plus, then 3 dots like that. And 3 dots in mathematics just means keep on going the same way you did before. And we put in the last one so we know where to end. You can also use variables in place of the numbers that you see here in the summation sign. So it's perfectly okay to write, for example, summation I goes from 1 to n, where n now is a variable and it must be an integer of xi. That then just means x1 plus x2 plus, keep on going all the way until you hit the nth x variable, whatever n is. If n happen to be 10, we have exactly the sum above, but n can be any integer now. So summation I go from 1 to n of xi is the sum of precisely n variables. In the same way, it's also allowed to have a variable for the lower number in the sum. So I can write I goes from m to n of xi, and that means that I should begin at m, whatever m is. I should add the next one, and I should keep on going until I hit the one at the top, that is xn. In this case, m and n must be integers, and m must be less than or equal to n for this sum to make sense. The next thing we can take a look at is when these xi variables depend on I. That is, they depend on the index itself. So I could have, for example, xi is simply equal to I. Here's the illustration with 10 variables where xi is equal to I. Here I have x1, so I is 1, so I have a 1 here. x2 is equal to 2, I equal to 2. For every x variable, the value that the x variable take is precisely the index of the x variable. So in this case, if I write summation, I go from 1 to 10, say, of xi, that would be precisely the same as I goes from 1 to 10 of I, and we can write that as 1 plus 2 plus 3 plus all the way to 10, which we find to be equal to 55. To do another example, summation I goes from 1 to 4 of I squared would then be 1 squared plus 2 squared plus 3 squared plus 4 squared. Or if you like, 1 plus 4 plus 9 plus 16, which is 30. It's also useful to know how to go backwards, that is, how to write an expression using the summation sign. So for example, if I have 4 over 9 plus 5 over 9 plus 6 over 9 plus 7 over 9. And I want to write that as a sum. I can write this as sum I goes from, now I can't write 4 over 9 because the indices in the sum must be integers, but I can write I go from 4 to 7, and in the summation sign I can write I over 9. That becomes precisely the sum on the left. Finally, just for convenience, if the end index is lower than the beginning index, for example, if I write I goes from 3 to 2 of xi, then we simply decide to define this as 0. If you think in terms of loops, this loop is basically empty, it will never run, so we will add nothing.